Hello dear students, in this session we are going to derive an expression for radius, frequency, time period of a charged particle describing a uniform circular motion in a uniform magnetic field. Okay, now what we will do, we will consider a uniform magnetic field, okay, going into the plane of the board. Say this is the uniform magnetic field going into the plane of the board. Okay, if I put into mark, what does it mean? Magnetic field is into the plane of the board. Okay, and if the spacing between all those into marks are same, then what does it mean? It means there is a uniform magnetic field. Okay, say this is, we have considered a uniform magnetic field in which, say there is a charge, okay, plus q, which is fired with a velocity v perpendicular to the direction of magnetic field. Magnetic field is into the plane of the board. Direction of velocity of the charged particle is this. Angle between them is 90 degree. Okay. Now, what is the direction of force experienced by the charged particle? So, you have to use Fleming's left hand rule. Forefinger will give you the direction of, if forefinger represents the direction of magnetic field, central finger represents the direction of motion of positive charge or the direction of current, then the thumb will give you the direction of force acting on the charge. Okay. Now, due to this, what happens is the charged particle will move like this. Continuously, there will be a force acting on the particle towards a particular point. Okay. Say the charged particle is here now. Charged particle is here. Okay. Now, what will be the velocity of the charged particle? Direction of velocity of the charged particle is this. Now, you apply Fleming's left hand rule. What happens? Magnetic field is into the plane of the board. Central finger should give you the direction of motion of positive charge or current. So, the thumb is giving the direction of force. See. Okay. Now, again, due to this force, what happens? The charged particle moves like this. When the charged particle comes here, okay, the direction of velocity is this. This is the direction of velocity. Again, apply Fleming's left hand rule. Forefinger will give you the direction of magnetic field. Central finger, see, central finger will give you the direction of motion of positive charge. Okay, so therefore the thumb will give you the direction of force. So this is the force. Again, the charged particle comes like this. Again, the same story. Okay, so velocity is in this direction. Magnetic field is into the plane of the board. Central finger gives the direction of motion of positive charge. Thumb will give you the direction of force. So therefore, the charged particle moves in a circular path. When a charged particle is fired perpendicular to the direction of magnetic field, then the charged particle will move in a circular path. In this case, what is the equation for radius? Okay. Now, how to calculate radius? Now, we have to understand who is responsible for centripetal force. If the charged particle is moving in a circular path, there has to be some centripetal force. That centripetal force is provided by magnetic force here. Centripetal force required for the revolution of the charged particle is provided by magnetic force. What is centripetal force? Centripetal force equation is mv square divided by r. That is equal to, magnetic force is equal to qvb sine theta. What is the angle between velocity and magnetic field here? 90 degree. What is sine 90? Sine 90 is 1. So therefore, just qvb I'll write. So 1v gets cancelled. So what happens? Directly I can write r is equal to mv by qb. This is the equation for mv by qb. This is the equation for radius of the charged particle which is moving in a uniform circular motion in uniform magnetic field. Okay. Now how to calculate the equation for time period? First we have to understand what is time period. Time period is equal to time required for one revolution. Okay. Time required for one rotation. Okay. So in one rotation, distance traveled by the charged particle equal to circumference of the circle. Okay. Time period equal to circumference divided by speed, because time means distance by speed. Okay. So what we will do? So therefore time period equal to what is circumference? 2 pi r divided by speed. Okay. Now we will make a substitution for this r. What happens? Time period will be equal to 2 pi by v into r. What is r? R, here we have written r equal to mv by qb. R equal to mv by qb. This v and v gets cancelled. Time period is equal to 2 pi m by qb. Time period is equal to 2 pi m by qb. What is frequency? Frequency is inverse of time period. So that is equal to qb divided by 2 pi m. So what is the important thing that we have to observe here is time period of revolution of a charged particle is independent of velocity. Means in the case of a uniform magnetic field, whatever the speed with which you fire the charged particle, time required for one revolution will be same. If the velocity with which the charged particle is fired is small, then the radius will be small. See, if the velocity is small, okay, then the radius will be small, but the time is same. If you fire the charged particle with very high velocity, then it will go in a very big circle, but it will take the same time. Time period of revolution of a charged particle in a uniform magnetic field is independent of velocity of the charged particle. Hope you understood the derivations, radius, time period, frequency. Thank you very much.